Hello everyone and welcome to another lecture in your general mathematics class. For today, we're going to solve logarithmic equations and also real-life problems in which we can associate logarithmic equations and functions. So before we proceed with solving, let us first define what logarithmic equations are. So a definition of logarithmic equation is equations involving logarithmic expressions are logarithmic equations. So basically, if you have an equation that involves logarithmic expressions, you can call that logarithmic equation. So examples are, we have here log with base 3 of 2x plus 5 equal to 2. We also have ln of x plus 7 equal to 1. And also the log of 3x equal to 4. So again, this ln here is our natural log. This means that the base is our constant e. This one naman, this means that our base is 10. So if our base is 10, we don't need to put 10 in the base, you need to write 10. So that is our definition of logarithmic equation. So before we proceed to solving logarithmic equation, let us first have a quick review on properties of logarithmic, or logarithm. So in our previous discussion, some properties were introduced to you. I will just add more properties that are essential in solving logarithmic equations. So we have here a theorem: let R be a real number and B, M, P, and Q be positive real numbers where B and M are not equal to 1. The following properties hold. First, if we have log with base B of the product of P and Q, that is just equal to the log with base B of P plus the log with base B of Q. So basically, ano lang, na extract natin si P at saka si Q. So vice versa yan. So if you're given this sum, automatic, that is equal to this, okay? The log of P times Q base B. So we also have here log with base B of the quotient of P divided Q is just equal to the log with base B of P minus the log with base B of Q. So similar lang sila, no? The difference lang is here product. So kapag product pala, addition, and kapag division naman, subtraction. Another one is if we have log with base B of P raised to R, that is just equal to R times the log with base B of P. So magiging coefficient lang yung exponent, no? Yan yung nangyari dito. And last, we have here the log with base B of P, that is just equal to the log with base M of P divided by the log with base M of B. So pwede mo siyang ihiwalay yung argument ng base, no? You'll introduce another base M. So this base M can take any positive number except 1, of course, no? So pwede nyo siya ni-rewrite to this form. This could be 10, 1, whatever. No, not 1. 10, 2, 1, 4, any positive real number not equal to 1. So yan. So let's try to have examples using these theorems. We have here, if you have log with base 2 of 3x, so this is product of 3 and x, so pwede yan ma-rewrite ng log with base 2 of 3 plus log with base 2 of x. So yun yung nangyari, no? Next, we have here log of x plus 1 plus the log of x minus 1 is equal to the log of x squared minus 1. Why? Because we have here addition. So, addition with the same base 10. So, pwede lang i-multiply or gawing isang logarithmic expression to, no? Which is just equal to the log with base 10 of the product of these two, x plus 1 and x minus 1, which is x squared minus 1. So, ayun. We also have ln of x plus 1 minus ln of x is just equal to ln of x plus 1 over x. Since we have the same again na base, e, and our operation is subtraction, so automatically we have x plus 1 divided by x as our argument no, sa ating logarithmic expression. We also have here log with base x of x to the power of 7. So, maging coefficient lang yung exponent na 7. So, that's equal to 7 log with base 2 of x. So, yan. So, madali lang, no? Let's try another, let's say, more complex example to that. Suppose we have log with base b of 2, that is equal to m. And then we also have log with base b of 3 equal to n. And log with base b of 5 equal to p. Now, using the properties given no, sa theorem, solve for log with base b of square root of 60. So, gagawin lang is express to siya in terms of m, n, and p. Okay. So, we have here log with base b of square root of 60. Square root of 60, gawin muna natin yung exponential form. So, mangyari, it will be equal to the log with base b of 60 raised to 1/2, diba? Since our index here is 2 and our power of 60 here is 1, so using the loss of exponent, that is equal to 60 raised to 1/2. So we have an exponent here, which is 1/2. And using the properties or the theorem, we know that 1/2 can be our coefficient na. So we have here 1/2 log with base b of 60. Now, we have 60. And we have here 2, 3, and 5. So if you prime factor 60, you will actually get 2 squared times 3 times 5. Okay? So 2 squared times 3 times 5 is actually equal to 60. So we have product na no sa ating argument. So, ang mangyari, we will use also the theorem. So, pwede ito silang ipaghiwalay. We will get 1/2 times this one magiging log with base b of 2 squared. So, nahiwalay sila, no? Plus log with base b of 3 plus log with base b of 5. So, ayan. Distribute natin si 1/2. Okay, before distributing 1/2 pala, we have here an exponent kang 2 squared. So, pwede natin siyang gawing coefficient. So, we have here 2 log with base b of 2. So, after that, we will distribute 1/2. Si 2 log with base b of 2 times 1/2, makancel si 2. So, you're left with log with base b of 2. And then, for the middle term, we have 1/2 log with base b of 3. For the last term, we have 1/2 log with base b of 5. Since this is m, this is n, and this is p, so our answer now is just m plus n over 2 plus p over 2. So that's log with base p of square root of 60. Ito lang pala. Okay, I hope na nag-guess natin yung mga properties and theorems because those are essential in solving logarithmic equations. So what are the steps ba in solving logarithmic equations? First is, you isolate the logarithmic terms on one side of the equation. Okay, no? So, gawin lang is, ilagay sa isang side lahat ng logarithmic terms. So, iwanan lang yung mga constant sa other side. Next is express as one logarithmic term. Okay, we will use our theorem here so that we could express our logarithmic terms as one logarithmic term. Next is write the logarithmic equation in exponential form. So we will use our definition of logarithm and exponent, no? And then fourth is you solve for the variable, and lastly check to make sure you do not have extraneous solutions. So we will apply these steps to our examples. Let's have the first example here. We have log with base 5 of x plus 8 equal to 3. So, na-isolate na ba lahat ng logarithmic terms in one side? Yes, cool. Isang logarithmic term lang ba natira? Yes, cool. So, next step is to transform this to exponential na equation. So, gagawin lang, di ba, is whatever the base here will be the base in our exponential equation. So, we have here 5. So, magiging 5 cubed. Right? Ito magiging exponent, si 5 base. X plus 8 as is. Okay, so we have here x plus 8 equal to 5 cubed. So as we all know, 5 cubed is just 125. So if we solve for x is equal to 117. So we have now our solution. Let's try to check if it's correct. So if we substitute 117 to x, we will have log with base 5 of 117 plus 8 equal ba siya sa 3? We'll see. So 117 plus 8 is 125. So again, if we transform this to exponential equation, we'll get 125 equal to 5 cubed, which is 5 cubed is 125. So correct. 117 is our solution to the equation. So this one is an easy example because it's already ready for step 3, transforming to exponential equation. So let's try another example. Okay, we have here the log with base 9 of x plus the log with base 9 of x minus 6 equal to 3 halves. So na-isolate na ba yung lahat ng logarithmic terms? Yes. Isa lang ba ang logarithmic term na present? No. So we need to combine these two. So by using the theorem, since both have the same base, so mangyari we have here log with base 9 of x times x minus 6. So product lang ng dalawang argument na to is equal to 3 halves. Okay, since we only have one logarithmic term left, pwede natin siyang transform to exponential equation. So mangyari we have x times x minus 6, si 9 magiging base, si 3 halves magiging exponent. So we have equal to 9 raised to 3 halves. So what is 9 raised to 3 halves ba? So this 2 in the denominator indicates a square root. So square root of 9 is 3, and then you cube that one, you will get 27. Okay, so we distribute, combine like terms. Okay, we have x squared minus 6x minus 27 equal to 0. Can we factor this one? Yes, no? In fact, the factors are x minus 9 and x plus 3. So therefore, our solutions now is negative 3 or 9. But again, do not forget to check, no? Actually, when I say check, the easier way is to look at the conditions. Diba, our arguments here is x and x minus 6. These two must not be equal to 0. I mean, must be greater than 0. So x should be greater than 0. Okay, so x can only take positive numbers. And in here, x minus 6 should be greater than 0. So therefore, x should be greater than 6. Note that in our original equation, x minus 6 should be greater than 0. And therefore, x should be greater than 6. And we have here negative 3, which is not greater than 6. So therefore, 9 is the only solution to the logarithmic equation given. Do you follow? So ganyan lang. Okay, let's have another example. We have here log with base 2 of 2x plus 1 equal to log with base 2 of x plus 2 minus log with base 2 of x minus 1 plus 1. So first step again, we isolate all the logarithmic terms. So siguro lagay natin siya sa left hand side ng equation. So if we transfer these two logarithmic terms to the left-hand side of our equation, the signs will be changed. No, this one will become negative, this one will become positive. Okay, we have that. We isolated all the logarithmic terms now. We will combine all those logarithmic terms. So we have here subtract and add. So technique lang guys is that all those na logarithmic terms na subtraction, tapos dapat always check if the base, yung base is the same, because it will not, kasi yung sa property dapat the same yung base. So in here, kapag subtraction, automatic yung argument is nasa denominator. Kapag addition, numerator. So mangyari, we have log with base 2, because we're multiplying x minus 1 to x plus 1, and then we divide x plus 2 to the product. So what we have is log with base 2 of the product of 2x plus 1 and x minus 1 divided by x plus 2 is equal to 1. Okay? So we only have one logarithmic term left. So we can now transform this one into exponential equation. So mangyari si 2 will be the base now, and then 1 is exponent. Then copy lang to. So we have this equation. So again, in solving rational equation, we need to eliminate the fraction. So by multiplying the LCD, which is x plus 2, we will get this equation. So if you distribute, you have 2x squared minus x minus 1 equal to 2x plus 4. Combine like terms, you'll get 2x squared minus 3x minus 5 equal to 0. Okay. Now, what are the factors of this trinomial, this 2x squared minus 3x minus 5? Can we factor this? Yes, no? Actually, the factors are 2x minus 5 and x plus 1. So therefore, our solution is negative 1 or 5 halves. Okay, so that's our solution. But again, we will not stop there. We need to check. So we need to check for the conditions here. So 2x plus 1 should be greater than 0, x plus 2 should be greater than 0, x minus 1 should be greater than 0. And then you get for the intersection of those conditions. So, since x is greater than 1 because of this term na log, no? Log with base 2 of x minus 1, diba? X minus 1 should be greater than 0, that's why x is greater than 1. Then we cannot have negative 1 as our answer. And so therefore, 5 halves is the only solution for the given logarithmic equations. So ganyan lang. So you always look for the conditions na dapat greater than 0 itong mga arguments natin. And then you get the intersection of that and the solutions who are inside, no, of the intersection, belong in the intersection. Yun lang yung solution. Yung hindi belong sa intersection, we can't get those value or values as our solution. So it's very important to see that one. So in solving exponential equations, we can actually use logarithmic properties also. Say for example, we have here 2 raised to 1 minus x equal to 3 raised to x. So diba in solving exponential equations, we try to make the base, no, equal so that we could equate the exponents. However, we can't express 3 as a power of 2 as well as 2 as a power of 3. So we're left with no choice but to use logarithm. So if we log both sides of the equation, we'll get log of 2 raised to 1 minus x equal to log of 3 raised to x. Okay, so if we have that one, we can now use our theorem. No? We have your exponent na 1 minus x and also x. So what will happen? We'll have 1 minus x times log of 2 and then x times log of 3. So naging coefficient lang yung exponents natin. So you distribute, you'll get log of 2 minus x log of 2. equal to x log of 3. So we're trying to solve for x here, so we need to isolate all those terms who have x na variable. So we'll have x log of 3 plus x log of 2. So ginawa ko dito is transfer ko lang to minus x log of 2 sa kabilang side. That's why I get x log of 3 plus x log of 2. And then equal to log of 2. So we factor out x, and then we divide both sides of the equation by with log of 3 plus log of 2, and you will get this as your value or solution for x. So this is now our answer. So if we try to simplify this one, pwede naman to siyang i-simplify pa. Diba? Since log of 3 plus log of 2 is just equal to log of 6, no? Because they have the same base. So we have here log of 2 over log of 6. And since log of 2 and log of 6 have the same base 10, so we can express it as log with base 6 of 2. So that is our final answer. Log with base 6 of 2. Okay? So try to answer these equations. Okay? So I suggest that you pause the video first and try to answer everything. And if you're done answering, you may continue playing the video. Okay, on the count of 3, I'm going to proceed with the answer. 1, 2, 3. So these are the answers for the following equations. So try to check it. So in here, I expected in equation number 4, you got more than one solution. However, the other solution violates the condition that the argument should be greater than 0. So it's only 1/4. No? Okay, so that's how we solve equations involving logarithmic expressions. Now let's apply those skills, no, in real life situations, no, that involves exponential and logarithmic functions, equations. So let's have an example. The very common example is exponential growth. And one of its example is the pandemic, no? The coronavirus, the spread of the virus. It's an example of exponential growth. So a new virus increases exponentially at the monthly rate of 2.8%. 4 months after the initial outbreak, there were 10,000 reported cases. How many were initially infected with the virus? Model the number of reported cases as a function of time. Okay, so we'll try to answer these two questions. But first, we need to understand what is exponential growth. So ang exponential growth pala is when the quantity is increasing exponentially at a rate r, then the quantity present at time t is given by p of t equal to p sub 0 times the sum of 1 and r raised to t, where p sub 0 is the initial quantity or the quantity at time equal to 0. So we have this formula, no, for our exponential growth. Actually, you can get it through common sense, mampod. Since this one is 100% and our r is the rate, so if you add that and then you multiply and then you raise it to t, it's just the same with geometric sequence. Okay. So let's try to remember this formula and answer the problem. So to answer the problem, we need to identify which values, no, are given in our formula. So ang given here is the rate 2.8%, 4 months, and then 10,000 reported cases after 4 months. So we have here the formula, given sa rate ng 2.8%. Of course, never, wag kalimutan na i-convert si 2.8% into this form. And then time 4 for 4 months. Then given ang number of cases after 4 months, which is 10,000. So we're actually trying to solve for the initial quantity, no? So P sub O. So if we substitute these values to the equation, we'll get this. Okay? Using PEMDAS, we add 1 plus 0.028, you'll get 1.028 raised to 4, and then divide both sides, you'll get P sub 0 equal to 10,000 over 1.028 raised to 4, which is approximately 8,954.2. So yan yung approximate number ng tao na infected at first. And now for the second question, the model. So ito lang, we need to substitute the values that are constant na dayon sa atong model. So we have P of t equal to, constant naman tong yung initial, which is 8954.2, and then constant din yung rate, which is 0.028. So ilagay niyan dyan. So ayan, nagawa na tayo ng function ng number of infected people as a function of time t, where your t is the number of months. So ganyan siya pag solve. So if there's exponential growth, of course, there's also exponential decay. Exponential decay is if the quantity is decreasing exponentially at a rate r, then the quantity present at time t is given by q of t equal to q sub 0 times 1 minus r quantity raised to t, where q sub 0 is the initial quantity or the quantity at time equal to 0. So basically, similar lang siya with exponential growth. The difference is just this operation, no? In exponential growth, this is plus. In exponential decay, it is minus. So let's have an example. Example of exponential decay is this one. Measuring the amount of carbon-14 enables an archaeologist to determine the age of artifacts and fossils. So if you're planning to be an archaeologist sometime, or in the future, so this is a good example and a problem for you. So in 1962, the skeletal and fossil remains of a woman were found in the Tabon caves in Palawan. The fossil was estimated to be 22,000 years old. What percent of carbon-14 remained in the fossil when it was found? Note that the half-life of carbon-14 is 5,730 years. Okay, so yan lang yung given. And we're trying to find the percentage of carbon-14 remained, no? Okay, cool. So let's solve it. Okay. Note that the half-life of a radioactive element is the time needed for it to be reduced to half its original amount. So yan yung meaning ng half-life. So we have here, diba, this is the equation of our exponential decay. So if 5,730 years ang atong half-life, so meaning if you substitute 5,730 to the time t, you will get this equation, this value, no, using our equation. And since we know that 5,730 years is the half-life of carbon-14, so meaning Q of 5,730 is just half of the initial, right? So meaning, if we substitute both to Q of 5,730, we'll get this equation in here. So if you multiply both sides by 1 over Q sub 0, we will get 1 minus r quantity raised to 5 730 equal to 1 half. And then you radical both sides, no? But 507 5,730th root both sides, you will get 1 minus r equal to 1 over 5 730th root of 2. Okay, so you'll have r. So if you're trying to solve for r, that's approximately 1.2096 times 10 to the power of negative 4. So that's our rate, no? However, we're not trying to solve for rate. We're actually trying to solve for the percentage left sa carbon 14. So, anong gagawin? We're not trying to solve for rate, but we need the rate to solve the problem. So, we know that it is assumed that the fossil or the skeletons are 22,000 years old na siya nung nakita. So, as Q of 22,000 should be equal to K of Q sub 0, which is R Q sub 0 is our initial, diba? So K here is the ratio of the remaining carbon 14. So if we were able to find K, we can get the percentage nila yun. So if we substitute this 22,000 to our formula of exponential decay, you will have Q sub 0 times 1 minus r quantity raised to 22,000 equal to K Q sub 0. Okay, makancel si Q sub 0 both sides. Okay, later na lang. So we know naman the value of r, which is 1.2096 times 10 raised to negative 4. So we substitute it, and then we cancel Q sub 0 both sides. So you're left with K equal to 1 minus 1.2096 times 10 to the power of negative 4. The difference raised to 22,000. So if you solve that, you will get an approximation of 0.0698. So that's our ratio, no? Na nabilin or natira sa carbon 14 in our fossils. So therefore, percentage man yung hinahanap. So meaning around 7% of the original amount of carbon 14 was remaining in the fossil. So ganun ang pag-solve niyan, ha? Okay. I hope that you follow. Let's have another example. Okay, no? So, again, exponential and logarithmic functions are also present in our business mathematics. So, one example is the compound interest. So, I use this example because all other terms and topics in business mathematics are all based to compound interest. The annuities, stock markets, those are basing compound interest. So first, let's have an example. Riley Blue put her savings worth 10,000 pesos in an account providing a compound interest rate of 3.5% annually. Okay? How long would it take for her savings to reach 11,875 pesos? Approximate your answer to the nearest number of years. So what are compound interest ba? So we have here the formula, no? A of t equal to p times 1 plus r quantity raised to t, where t is the time, r is the rate, and p is the initial deposit borrowed. So if you can observe, this is somewhat similar, no, with our exponential growth. Yes, because compound interest is an example of exponential growth. So let's try to solve this problem. So we have an answer na here, 2 years. So let's see how do you get 2 years. So of course, we will list all the given ang rate na 3.5%, given rin ang initial deposit, which is 10,000, and given rin ang amount after a certain time, which is 11,875. So what's missing is the time t. So if we substitute these values to our formula to compound interest, we'll get 11,875 equal to 10,000 times the sum of 1 and 0.035 raised to t. Okay, so this is 1.035. So if we divide both sides by 10,000, we'll get this. Okay, so we're trying to solve for t here. So we can transform this actually in, this is an exponential equation. We'll transform this to logarithmic equation. We will get t equal to the log with base 1.035 of 11,875 divided by 10,000. So if you solve that, you will get an approximation of 2 years. Okay? So transform lang tayo from exponential to logarithmic form. I hope you follow. Okay, try this problem. Your father wants his coffee served at 65 degrees Celsius. After you brewed his coffee, he noticed that after 5 minutes it cooled from 88 degrees Celsius to 82 degrees Celsius in a room whose temperature is 20 degrees Celsius. How long should you wait until you serve him his coffee? So note that Newton's law of cooling states that the temperature of an object at time t can be modeled by t of t equal to t sub a plus c e raised to negative kt, where t sub a is the temperature of the object's surroundings and k is the rate of decrease of the object's temperature. So yan. Given ang Newton's law of cooling, try to solve this problem. So hint here is that you make use of the given, no, using the formula. So I think given naman dito yung yung surrounding na temperature. Given rin yung initial na temperature. Try to utilize that. Okay, you may pause this video while you're solving and then unpause when you already have an answer. Okay, so I'm going to continue in 3, 2, 1. So the answer for this problem is actually approximately 22.35 minutes. So I hope you get that correctly. And I also hope that you understand the concept or the ways in solving logarithmic equations. And also how to apply them in real life situations. So, ang daming applications ng ating logarithmic and exponential functions. Not just in business mathematics, in chemistry, physics, also in statistics, engineering. All fields actually involves exponential and logarithmic functions. So I hope that you have a good grasp of what's an exponential function and logarithmic function now. Thank you for listening. God bless everyone.